Hi, I'm Richard from First Machine Tool Accessories, and I'm here today with Steve to have a bit of a chat about mandrels. Steve, so where would you need it? What's the application for a mandrel?
Uh, Mandrel is a very good way of holding components accurately from the inside.
From the inside.
From the inside. So bored hole or U-drilled hole even, we can insert the mandrel and hold the component. Because there's a huge amount of surface area there, you
Right.
don't need a lot of pressure to actually exert a lot of force on the component. So you can be quite delicate or hold them very, very rigidly and strongly and very accurately because they're on line the spindle.
Right. I mean, there are some jobs that probably can't really be done any other way.
Yeah, there are certain jobs that can't be done any other way. If you put an internal bore in a component and it's an unusual shape, that one you're holding is quite
Right.
good to show. So to actually make that one on a lathe complete, you can do the front end and put a bore in. That can be transferred to the sub spindle on a mandrel, and you can then finish that component complete. You're not parting it off. It's a finished component. No more operations.
Yeah, that's a good point. Second operations on lathes with the sub spindle.
Yeah.
After you've done all your interior features and turned all your interior features, that's probably a very good way to grip then to give you complete access to the outside of the component for your second operation.
Yeah. We also, these are filled.
Right.
So you have a rubber insert, so there's no swarf ingress.
Excellent.
So you take the component off,
Yeah.
small bluff or coolant will wash it clean, ready for the next component.
Now that sounds to me like a feature that you would really benefit from in an automated system.
Yeah.
Where you don't have human involvement who can check for things like swarf ingress. Are these applicable to an automated system?
Yes, they are. Yeah, if these are on a sub spindle, you can load your first end, either bar end or robot load to the main spindle, do the operation, transfer to sub spindle, do all your work, and then take it off of the robot very cleanly and easily from a mandrel.
Right.
And you've got no swarf on there to go again. So it's a very easy system
Right.
to run and use.
So the 1stMTA range of mandrels, what does that incorporate? The standard range of mandrels.
Standard range of mandrels, 12.4 to 82.7. It sounds unusual, but there is a reason why that. So each band, we call them AS, BS, CS, DS, ES, each one covers a range of sizes, but they overlap each other.
Right.
So although it's a standard range, but then we can grind to any diameter that people want within that range.
Okay. Okay. So you have standard sizes and you can supply custom sizes as well. What's the sort of largest you can really go?
Fairly big, really, if you're talking that sort of size and bigger.
Sort of 300
it really
or 400
depends.
millimeters.
Yeah, you can go very big. Obviously, those ones you're looking at quite complex things like turbine rings. You might want to machine the airfoils on the outside.
Right.
Those ones are different from the standard ones where we preload those with springs.
Okay.
So if your machine goes down, there's an electric cut, it doesn't release and let go. It's always under tension.
Yeah.
So you actuate it to put the component on rather than the other way around.
Okay.
So it just protects your expensive components. So
excellent.
So that's turning size, but this one we can go milling. So this is static chuck, a pneumatic chuck.
And does that have a built-in cylinder?
That's got a built-in cylinder, air operated, pneumatic. So this is a milling machine or static components.
Right. And that looks like a manual one to me.
That is a manual one, yeah. Yep. So that has the same range on the manual. This will just go in your standard old-fashioned 1950s manual lathe.
Right. And you can then have that added work holding ability in an older lathe with a standard 3-jaw chuck.
Yeah, just put them in a set of soft jaws and away you go. We've moved on to this. This is a quick change system that's been developed. It's quite new, it's still in plastic.
Right.
But that's bolted to, that's the actual spindle mount.
Right.
So you can quick change. If you have a series of mandrels, quickly and easily do up and go again.
And that connects.
That's connected through here to the draw tube.
To the draw tube.
The draw bar, sorry, I should say.
So
and if you want to change, undo, snap off, and then put the next one on.
So you can quickly go between the different series of mandrel sizes.
Yeah, between the whole range.
And still have full automation on your production because you're using your power chuck through the draw bar
itself. Yeah. So it's really easy. So these are fairly standard components, but mandrels are not just singles. We can stack these.
Right.
So if you've got a long tube, for instance, or a long aerospace part that has a fine bore in it, and you need to machine the outside or grind the outside,
Right.
we can stack these into multiples, and you can probably get up to 900 millimeters long.
Wow.
With stacks. They'll be supported at one end
Right.
from a centre, but we can hold accurately and firmly so you can then either machine the component or grind the outside.
I mean, that's a very awkward job to do. Something you
Yeah.
need to grip in a bore that's that kind of length, especially in a smaller diameter. I can't think of any other way that you could easily and accurately grip a job like that other than using a mandrel in a system like you just mentioned.
Yeah. I mean, there is a limit to the diameter we can go down to
Right.
for the stack, but we can go down to certain diameters. We'll go down to them, and what we do is, because the whole system actuates from the front and it pulls, what we do on a stack system, we will grind a different diameter on each of the mandrels.
Right.
You're only talking probably a thou, 0.025, and what you'll do, as it actuates, it will grip one place, next place, next place, next place. So you're not overloading one end of the
Right.
component and swelling it
So
and
it's a
causing
sort
bruising.
of progressive
Yes.
clamping application.
Yeah. The first one grips, holds in place, and then the next come in. But it's so fine you wouldn't see it.
Right.
But it just means that you get consistent gripping forces.
Wow. So that's a big range. I mean, we've got manual, simple mandrels,
Yep.
milling machine, built-in cylinder, so you can have that automation on your milling machine on a mandrel system, and then on the CNC lathes.
Just say front end like this, but on a CNC
Right.
unit.
Yep.
Very simple.
Very simple. And then onto a quick change system that allows you to change out your mandrel series very, very quickly and easily.
Yeah.
Well, thank you very much for having me,
No.
Steve. Really appreciate that. That's been very informative.
Good. No, thank you, Richard, and hope everyone out there's got some good information.